So what is a barometer? Now a barometer is used to measure pressure. Usually the pressure in the outside of the barometer, which is usually the atmospheric pressure lah. So I'm sure what you have learned before last time is that you simply said that the pressure, atmospheric pressure outside, is equals to your H times the density of the mercury inside the barometer times the G. But how many of us know how they came up with this formula? Alright, how did they arrive at this formula? So you need to understand the principle behind a barometer. Okay, now something is called a 14 barometer lah. So in a 14 barometer, what usually happens is inside here is a vacuum. So you imagine when they first started off, inside this tube here is just vacuum, there's nothing. So but if you put it inside the mercury, air which is outside has higher pressure than inside, because inside is vacuum, right? And you know air, like all gases, they want to travel from higher pressure to lower pressure. But as the air wants to go inside the tube, which is a vacuum initially, it will encounter the mercury in the way. The mercury is in the way, correct? So that means as it tries to go in, it will push the mercury up. That's why the mercury rises. But as the mercury rises, the mercury, which has a weight, will then exert back a pressure. Do you understand? So when will the mercury start rising? When the difference in pressure between outside the tube and inside the tube is equals to the pressure exerted by the column of mercury. So by right, the actual formula is the difference in pressure, delta P, which is difference between outside and inside the tube, will be balanced by the pressure of the mercury column, which is H rho G. But since in a typical 14 barometer, the inside of the tube is vacuum, so when you take out pressure outside, which is atmospheric pressure, and you minus the pressure inside, which is vacuum, which is 0, so you get H rho G. So that's how we got the formula atmospheric equals to H rho G. So this was in your earlier standard, earlier form or O levels or SPM, that's what you learn. But in A levels, you learn another step, okay, something a bit advanced. So sometimes you will find that there will be gas inside the tube, so it's not vacuum. So when there's a gas inside the tube, then you have to take the difference in pressure, which is atmospheric pressure, all right, in this case the same atmospheric pressure, minus the pressure of the gas inside. Then only you'll get H rho G, that's it. So the basic principle is just this formula. Difference in pressure equals to H rho G. That's what you must know. Okay? So another device that we can use to measure pressure is called a manometer. And sometimes it is called a J tube or a U tube. A U tube means both ends have the same height. But if one side is lower, one side is higher, then they call it a J tube. Okay? So anyway, it's the same principle in a manometer. So the idea is, for example, there's a gas inside here. What will happen is the gas here will exert a pressure which will push the level of the liquid here. So let's say we start off with everything is mercury. So the mercury in the tube will start going down because of the pressure here. So it pushes down, understand that? And on this side, atmospheric pressure will push back. So it will stop moving, that means the liquid will stop moving, and then you will get a fixed height here. And what does it mean? Now, when you get a fixed height, the first thing you should do is to find the level which is common on both sides. Now, what do I mean by level which is common on both sides? Do you realize the mercury here and up to here is the same? That means if I take this part, they are identical, symmetrical to each other on each side. So we take this level which is symmetrical for both sides. Understand? So since the level here and the level here are the same, that means the pressure above it is equal to the pressure above this. Do you understand? So find the common level, that means these 2 points will have the same pressure. Above this is what? Pressure of the gas. Above this is what? Atmospheric plus H rho G. That's how you use it. So you can use different types of situations, even involving multiple liquids. For example, let's say there's another tube here which contains 2 different types of liquid. You could have oil here, or let's say you use mercury and then we use oil here. Okay, so we use oil. And on this side, we even add a container here and we put there a certain pressure of the gas, whereas this side is exposed to atmosphere. So what is the equation to represent this? Once again, you find the common level on both sides. So up to which part is it symmetrical? Isn't it up to here? Which means to say whatever here is the same as whatever here, right? So whatever pressure above this point is equal to whatever pressure above this point. So you can write the equation as pressure of the gas, which is on top, plus, now let's give this height as H1. So plus H1 density 1 G, because let's say this is oil, must be equals to the right hand side. So what is on the right hand side? Atmospheric pressure, plus, let's say this height here is H2, plus H2 rho 2 G. So that's it. It's very straightforward formula. Okay?